Okay, so here it says find the roots, which means to solve this quadratic equation. So now this question looks different from the questions before this week because it has this equal 0. It's now an equation, not just an expression that we factor. When it's an expression, you factored it and then you were finished. With an equation, factoring is just going to be the first step. So first, I always look whenever I'm factoring to see if there's a GCF I could divide everything through by, and in this case, there is not. So that's not the method I'm going to use. What does this look like? You could look back to your notes and the mapping I gave you of deciding which method to factor, and this is going to be add multiply. So my factors of 2, not many, just 1 times 2, but it has to add to negative 3, so they're both going to be negative. So that gives me my two factors, x minus 1, x minus 2, but now I also have to bring down the equal to 0 to complete the equation. Now, once we have it in factor form, we use the zero product property to say that either the first factor is equal to 0 or the second factor is equal to 0. We solve each of these equations. The first one gives me that x is equal to 1. Adding 2 on both sides here, I get x is equal to 2. Now, that's finished. Your solutions are 1, 2. You do not have to write it in solution set form, but I want to take a moment and show you the connection to the graph of this equation. So I had already typed all the equations in, so this is the first one. And now I want you to look at the graph and look at the solutions we just got and see if you could find a connection of how looking at the graph you could find when this equation x squared minus 3x plus 2 is equal to 0. Where is the graph equal to 0? On the x-axis. Now look at where the graph crosses the x-axis. I can't point to it, but trace the green parabola with your finger or with your eyes and check out where it crosses the x-axis. Do you notice that it crosses the x-axis? Graph crosses the x-axis at 1 and 2. Okay, if you can't see the values that they cross, you could hit the 3 dots next to the equation and then special points. And if you scroll, do you see roots? The roots show you that when x is 1, the output's 0. When x is 2, the output's 0, giving you the solutions 1 and 2. So that's a way that you could check graphically, because I do need to see the work. Just answers, you're not going to receive full credit. Okay, I'll do the next one in this video also. So again, we're finding the roots. First thing you're going to do is factor, and the first thing I look for is something I could divide the terms both by. And I could divide them both by 2x. So I'm just factoring the left-hand side. So I bring the 2x to the left, and then I'm going to divide through. The 2's go. X squared divided by x is just x. 14x divided by 2x's, the x's cancel, and I get 7 equal to 0. And again, don't forget to bring down that equals 0. Again, I'm going to tee it off between the two factors. The first factor is 2x. That could be equal to 0. Or x plus 7 could equal 0. The first equation, 2x equals 0, I'm going to solve by dividing both sides by 2. And 0 divided by 2 is 0. That's your first solution. Minus the 7 on both sides, you get x equals negative 7. So your solutions, I like to always put the smaller number first. You wouldn't get it wrong if you didn't. You don't even have to put it in solution notation. And now let's look at the graph of number 2. So I'm going to turn off that graph and turn on that second graph. And where does that graph cross the x-axis? Either, if you can't see it again, I could hit the 3 dots next to that equation, special points, and now the special points are for this graph. If you look down where it says roots, it says E and F. negative 7, 0, and 0, 0. So those x values, negative 7 and 0, are your solutions. So you could do that for all of them. I'm not going to keep showing you guys that. That's more really the next topic we're going to do after this week. So for now, you really just have to be able to solve algebraically and get your solution set.